Okay, hi guys. So we'll be continuing on seeing more notes on titration. Okay, so let's get started. So when reactants react with each other, their moles may or may not be same in completion of the reaction, but their number of equivalents are same. Okay, so we are talking about the titration, which we saw in the previous reaction or previous lecture. So when reactants react with each other, their moles may or may not be same at the completion of reaction. Okay, but their number of equivalents are same. Valents are same. Okay, so now let's see the law of equivalence. Okay, so number of equivalents of A reacted is equal to the number of equivalents of B reacted, which is equal to the number of C formed or produced. So law of equivalence says that number of equivalents of A reacted would be equal to the number of equivalents of B reacted, which in turn would be equal to number of equivalents of C formed or produced. Okay, so number of equivalents of a substance is defined as is equals to weight or mass of the substance divided by equivalent mass of the substance, equivalent weight of substance. Okay, so this is how the number of equivalents of a substance is defined. Okay, so this is the first part, and the second is how do we calculate the equivalent mass. So equivalent mass or equivalent weight can be calculated with molecular mass, or you can also say molar mass divided by n factor. Okay, next let us define what is normality. Normality, n, it's denoted by n. So n is nothing but number of equivalents of solute over volume of solution. Number of equivalents of solute divided by volume of solution in liter. Okay, so just remember this, it's a very important formula or very important concept. So let's see the correlation with all of the three terms defined above. So correlation is that we have number of equivalents of a substance is equal to weight or mass of solute, or rather weight or mass of substance divided by equivalent mass. Okay, and we have equivalent mass defined as molar mass or molecular mass of the substance divided by n factor, and number of equivalents so this was the third equation which we discussed here, and this is the fourth one, that the number of equivalents is equals to number of moles into n factor. Okay, this implies that normality, which is equal to number of equivalents of solute, number of equivalent of solute would be nothing but so let me rewrite it. So before that, I hope you all can relate that how we came to the fourth equation. So if you want to calculate this is the number of equivalents, so just put the value of equivalent mass from this equation to here. So you will get weight or mass of substance divided by molar mass, and in the numerator it will come multiplied with n factor. Okay, and mass of substance divided by molar mass is nothing but number of moles multiplied with this n factor which goes into the numerator. So number of equivalents is number of moles into n factor, and normality is nothing but, let me rewrite it, number of equivalent of solute divided by volume of solution. Okay, so number of equivalents can be written as number of moles into n factor divided by volume of solution in liter. So number of moles divided by volume of solution in liter is nothing but molarity. So this implies normality is molarity into n factor. Okay, this is a very important relationship, just remember it. Okay, so number of equivalent of substance can be written as, so just deriving from the already seen formula, that number of equivalent of a substance in normality terms can be written as normality into volume of solution in liter. Okay, and now in the next lecture we'll be seeing the calculation of n factor, because the only term which is new to you is n factor here. So in the next lecture we'll be taking up the n factor concept. So we'll meet in the next lecture. Till then, good luck and goodbye.